This is lesson 4-6, average rate of change. Functions are rules that give us the outputs when we supply them with necessary inputs. From here on out, we're going to have several instances where we need to know how rapidly functions are changing. We're going to be able to compare several functions when it comes to how quickly they're changing compared to the same input values we put in each of the functions. The average rate of change is the measurement of how fast any outputs are changing based on input values. To measure the average rate of change from point A to point B, we simply plug it into this formula where f of b minus f of a on top of a fraction, and then b minus a on the bottom. If this at all looks familiar, it's the same exact formula for measuring the slope of a linear function. Let's take a look at a guided example. There's a lot here. What I'd like you to do is write the guided example. I'd also like you to sketch the graph to the best of your ability in your notes. You should pause the video at this point to give yourself a chance to write all of this down. All right, let's take a look at the guided responses. First, how do we interpret the fact that m of 12 is equal to 30? Illustrate the response by using the graph. So, m of 12, again, look at the graph and notice that we are going up by 2's. So m of t is this line, the lower line right here. This is max. m of t is equal to 30. It's right there. How do we interpret that? Meaning that at 12 seconds, Max ran 30 feet. Remember, we're talking about Evie and Max in this problem, and we are determining how fast they are running. So at 12 seconds, sorry for my poor writing there, that should be an S. At 12 seconds, Max ran 30 feet, and I did illustrate it on my graph right there. If both runners start at t equals 0, meaning 0 seconds, how much of a head start did Max give his little sister? How can you tell? Well, let's take a look at the distance. Max started at the 0-foot line. This is Max, because this is m of t. Evie is e of t, and she started up here. Clearly, we're going up by 5. That means that Evie got 25 feet for a head start. How can you tell? Evie's function starts higher on the y-axis. Does Max ever catch up with Evie? How can you tell? Max may eventually catch up with Evie, but Evie at the end of this graph is still right here, and Max is right here. At no time did Max catch Evie, so the answer is no. And basically it's because the functions never crossed. How fast is Max going? How fast is Evie going? So now we want the speed, which of course is a measurement of the distance over time. So we need to know how fast they've gone. Let's start with Max. I can take any 2 points I want, and since I've already illustrated 2 points, with this one at 0, 0, and this one at 12:30, I now can use my rate of change formula for this. So for Max, I want to do f of b, so we'll call this point b, and we'll call this point a. So f of b in this case is going to be 30. F of a is 0. And f of b is 12. And f of a is 0. Doing those calculations gives me 30 over 12, not 36. Pardon my writing there. 30 over 12, which is equal to 2.5. And what are we looking at? Feet per second, because this is feet on top and this is seconds on bottom. So 2.5 feet per second. Let's take a look at EVs. We have 2 points as well. I have 0.25 and I have 20.60. So I'll use those 2 points for EV. I'm going to move right up here for EV. Hopefully you're following me. Sorry for the limited space. But EV is going to be f of b. Again, we'll call this point B and this point A. F of B, which would be 60, minus f of A, which is 25, over B, which is 20, minus A, which is 0. 60 minus 25 is equal to 35, and 20 minus 0 is equal to 20. We do that, and we end up with 1.8 feet per second. So Evie is going slower, but in this graph, Max never catches her. So here's an example for you to try. Let's consider the function f of x is equal to x squared plus 3. Find the average rate of change from -1 to +3. Pause the video at this point to give yourself a chance to try it on your own. So the first thing I need is I need to find the values of the function at -1 and at 3. The value of the function at -1, we have -1 squared plus 3. -1 squared is a +1 plus 3 is 4. For f of 3, we have 3 squared plus 3. 3 squared is 9, plus 3 is equal to 12. Now to calculate the average rate of change, we'll take f of 3, which is 12, subtract f of -1, which is 4, over 3 minus -1. Doing that calculation, 12 minus 4 gives me 8. 3 minus -1 gives me a 4. So my average rate of change here is 2. Here's the last example. Give you a function table and want to find the average rate of change over the interval 2 to 6. Pause the video at this point to give yourself a chance to try it on your own. Here's your answer. At h of 2 is 9. At h of 6 is 3. So we're going to use our rate of change formula. F of 6, which is 3, minus f of 2, which is 9, over 6 minus the 2. Now we have 3 minus 9, which is -6, and 6 minus 2, which is 4. When we do that, we get an ugly looking decimal. So we are more than welcome to leave it as -6 over 4 for this particular rate of change. If you're having any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.